and I'm going to be the trainer for today. So last week we had like two different sessions, Git, Git and GitHub version control. We had that from Aaron, who isn't around today, and I hope you guys check out the video on YouTube. We had another session from Joseph Amukon, who is also a trainer, and it's also been posted on the YouTube channel. You guys can go and check it out. So today, mainly, I'm going to continue from where Aaron stopped, and this is the part called deployment. Share my screen. So today, I'm going to take you through the deployment phase within software development. But before that, some of you might not know me. Niwasima Ashley Cole, a software engineer. I'm also a trainer at Akili Kesho, a tech entrepreneur, and maybe let me show you my GitHub and you see how a professional GitHub should look like. This is a README file from my GitHub. Shows my names, what I do, how you can contact me, my identity, location. This is a file that you should at least add to your GitHub as well, so as to improve on the visual appearance and also showcase that you're actually a professional. Some of the projects that I work with, the tech stack, what I'm building right now. Actually, GitHub is like a digital CV to most of us, because as a developer, if your GitHub is really active, you can just send a recruiter your GitHub account and they know that you're actually building something and they know the skills that you have as a developer. So this is me. And today's training, as I told you, is all about deployment, shifting from localhost to the cloud. So again, this is me, Nwasima Ashliko, trainer at Akili Kesho, focused on building the digital capacity, engineering local fast ecosystems, and mentoring developers across Uganda. My credentials: I'm a co-founder and CTO at Renault, which is a software development firm. I'm an active GitHub contributor here in Uganda. I think I'm like the 150, something like that. I've also been recognized as a third prize winner for the Huawei ICT competition, because I represented Uganda, the entire Uganda and Africa within the region. You can check me out on my LinkedIn, GitHub, my portfolio. So this is today's learning roadmap. I'm going to take you through an SDLC. An SDLC basically is the software development life cycle. This is what you need to know as a software engineer, because within the tech field, there are procedures to follow to build a professional software that meets the standards of development. I'm going to take you through the cloud architecture, the full stack providers of the cloud, version control orchestration, and the automated pipeline. Hope I'm not fast. So, as I told you, an SDLC Software development, there are procedures to follow, and that's the SDLC. This stands for the software development life cycle. The software development life cycle is like a blueprint that we software developers use to build a software. You have to first plan. From planning, you design or architect, then you build. From the building, you check and maintain software. It's a that guides teams through each and every stage of the project, from the initial idea to the way the project is going to be run, developed, and maintained. As you can see, the first step is the planning stage. From planning, you go to design. From designing, you go to coding. From coding, you go to testing. From testing, you go to deployment, which you are going to focus on today. And from deployment, you go to maintenance. This is how software is run on the industry standard. So phase one, as I told you, is the system planning. This is the foundation of every successful project before even a line of code is written. You identify the problem. What problem are you going to solve as a developer when you're developing that piece of software? What are the technical specifications needed for that exact software? The scope or set constraints. What's needed? Are the software programs you're going to develop, will they be able to run on the architecture that you have, on the programs that you have? All that is within the planning phase. Identifying the problem, the technical specifications, those are the requirements or the system constraints. These are what you should be focused on when you're developing a software. The phase two is the architecture design. This might be a new term to most of you, but when you're designing software, you have to first know how will the software flow from the user to the system, from the system to maybe the end user, from the developers. Each and every stage within the system is first drawn before it's actually written in code. As you see, before coding begins, teams structure the entire application from how users interact to how data flows behind the scenes. You might see a good application, but you don't know how everything is run, how the information flows within the software. All that happens within the architecture design. Here there are things like a context diagram, uh, data flow diagram. All these explain to users how the information is going to flow within the system. As you can see in the design, the UIs, the styling patterns, the data patterns and relationships, all these are within the design phase of the SDLC. So phase three, this is the coding. This is the part that most people think software design is all about. People think that when you write a piece of code, then you're a developer. But no, a software engineer should be disciplined and most cases should follow an SDLC staging plan. And even in the era of AI, whereby you can just, let me say, vibe code an application. To do that, you must first understand how will information flow from the system to the user, from the user to the system. All that is within the SDLC. And as a good software engineer, you should know all these steps before you even write a single line of code. As you see, writing functional software syntax inside your text editors like Anti-Gravity, VS Code, or any other that you use, Casa, name it. This is the fine-tuning of features designed into living interactive code engines. That's the coding stage of the SDLC. Then the testing. Here there are many types of testing: the user acceptance testing, the quality assurance, but all that will lead you to development. Before deployment, teams locally debug applications to catch issues early so as run things clearly after deployment. So as you see, you first debug because most cases you can't write a piece of code and you find it's completely accurate. I've never seen that because most cases if you write code, at least there is some error that you've missed, and an error in code is called a bug. So you have to first debug, look for different errors within your code, then debug before deployment. So the deployment phase, this is the main objective of today. This is where you understand why code on your machine isn't enough, what it truly means to put out your application in front of users. Most cases, people think that deployment is maybe the biggest step within software development, because you might be having the code on your machine, but you fail to understand and push out everything. When you're developing software, you need to first know that who am I developing the software for, and they need to first at least use the application before it's fully launched, and to show a person that you're developing something, you must deploy. Keeping code on your machine alone doesn't get you the users, doesn't get you the feedback that you need, or even doesn't get you the value within the code itself that you have. So the localhost sandbox environment. Most people might think that software development is about maybe developing the software and you leave it there. But software should be deployed, not left on your local machine. So localhost this exactly on your machine through servers like localhost, or even IPs. This means that the code is restricted to entirely your device alone, and it's not open to anyone. Let me show you an example of local hosting, because this is a project that I want us to deploy together at the end of the program. I designed a simple HTML, CSS, JavaScript static website that is to show you how to deploy. Now, this static website is on localhost, so it's not like I can share with you the link and you access it. But once it's deployed, I can be able to share with you the link and anyone can access it anywhere with it all over the world. Those are the advantages of localhost and of deployment. So let's proceed. So your application exists only inside your own machine. No one outside your device can access it. Not a colleague, not a client, not even a user. The code is function. The code is functionally invisible to the outside world. This is what I was saying. Once your code is on localhost, no one will ever know that you built something. So in this era that you are in, is to deploy so as people know that you're actually building. This is an example of a product that I'm working on and it's still on localhost. But for me to actually show it out to the entire world, I have to first deploy it. Right now, I can't share it with anyone because it's still on localhost. So these are maybe the disadvantages of localhost. They are like why localhost fails your users. A single point of failure. If your computer shuts down, the application goes offline. So no one can access the application when it's on localhost. The entire application's availability depends on whether your machine is powered on or off. When your machine is off, the application isn't online. When the machine is back on, it's when the application is online. So no external access. Localhost links are completely inaccessible to external mobile clients or remote reviewers trying to see your app. So no one outside your local network can actually see what you're actually building. So most cases when it's on localhost, it's not production ready. A local environment cannot serve real users. It's just a sandbox by design, useful for deployment, but fundamentally incapable of supporting a live application. As I was saying, when your application is on localhost, you can't send it to any reviewer or any end product user to actually see what you're building. So the deployment, this is actually the magic of programming, whereby you can showcase what you're actually building. Code deployment is the technical transition of copying code files from your private computer and putting them on an enterprise server built to stay active 24/7, 365 days a year. This transition moves code from a private machine-bound state to publicly accessible, always on environment whereby users can interact with the application anywhere at any time of the day. It's available 24/7. So deployment isn't just uploading files, it's the deliberate act of moving your code from private, fragile environments to public infrastructure designed for continuous availability. So this is just an analogy, like typing a novel on a paper in your room. The work only exists for you to read. It's not a distribution, no audience, no reach beyond your own desk. But take deployment as you're a writer and you have published your work and you've made thousands of copies and they're available in every bookstore all over the world. Your work becomes accessible to the readers worldwide, distributed and available at scale. This is how deployment works. When your application, website, or anything is deployed, it's accessible to anyone in the world, whether the person is within the US, whether the person is within Madagascar or Alaska. Anyone can access your code provided you have sent them the link or they know where to access it from. This is just a code. If your engineering if your engineering code is not deployed on a live public cloud server link, it doesn't exist to the real world digital economy. As I was saying, if your code stays on your local machine, no one will ever know that you're actually building. But if you code and deploy, people will actually know that actually the guy is actually building something. Because in this era that we're in, the digital visibility is about building in public and publishing what you're actually building. Because thousands of companies have actually scaled just because of building in public and deploying. Companies like Cruelly have reached to over $1 million valuation just from that. So cloud infrastructure. So before the cloud, companies had to buy physical computer units, install them in office closets, or even manage raw power inputs manually. This is an era whereby companies had to buy servers, thousands and thousands of servers. Companies like AWS, Google still have the servers, but we have transitioned from that era to a cloud-based era, whereby this this is very different from what we had. The on-premises architecture of the servers had its disadvantages: the high maintenance costs, the physical security risks, and the powerful outbreaks. On-premises infrastructure carries high local maintenance costs. Companies must continuously manage hardware, power inputs, and physical systems, all requiring dedicated resources and expertise. The physical risks included the physical hardware being exposed to security risks that cloud environments abstract away. Locked office utility clauses provided limited protection compared to the enterprise-grade cloud security that we have currently. So the power faults and blackouts. If a single neighborhood blackout instantly crashes your worldwide system, when your infrastructure depends on local power, any local disturbance becomes a global out, outage. When you're using a local server and you run into a power blackout, so it means your site is no longer available till the power comes back. Hope guys I'm audible and you're following me. Hope I'm not too fast.
Yeah, I think you're okay.
Great. So now we have come to an era of the cloud. Cloud cloud we are not meaning the clouds within the sky, but talking about the digital the digital infrastructure. The cloud isn't just magic. Actually, the cloud isn't magic air. It's just simply someone else's ultra scale data center facility managed by cloud providers like AWS, Google Cloud, Huawei Cloud. All these cloud platforms offer you, let me call it, infrastructure as a service. Then they provide you space and you do whatever you want with it. I've actually been able to use Huawei Cloud. It's quite good, plus AWS, Google Cloud as well, but not that much. Instead of buying and managing your own physical hardware, you leverage these providers' massive infrastructure. Facilities built for scale, reliability, 24/7, 365-day availability. The cloud abstracts away the physical complexity, letting you focus on the application rather than managing raw power inputs and hardware. The cloud itself a good is a good place to focus in software, because there are roles that are available within the cloud, like cloud engineers, and they're highly paid as well. So as I was telling you, cloud platforms provide different services. There is the last pass. So last, this is the infrastructure as a service. This is where you're provided virtual machines. You're just renting plain virtual blocks, meaning that the complexity of the terminal windows to install custom operating systems like Linux, manage network firewalls, and bind ports from scratch. You're the one in control of everything. That's the infrastructure as a service. But this current era, most software developers focus on the PaaS, the platform as a service. So modern PaaS engines automate infrastructure development entirely. They hide the system server settings, leaving developers free to focus 100% on the code quality rather than the complexity of managing the entire virtual machine. The PaaS removes the operational burden so that you can ship faster. Platforms like these are the ones currently being used. So the PaaS in the modern default for most application deployments. It eliminates the infrastructure complexity, so you can concentrate on building your project rather than the complexity of managing the server itself. So network speed and security. This is understanding how the code is delivered, accelerated, and protected across the global internet. This is whereby we talk about how a Ugandan developer can develop maybe a software and a person in the US can be able to use that same software, and it's delivered and actually protected across the global internet. In code bases, there are different types of maybe code. Let me say, when you're developing a website, you might develop a one-page website that's called like a static website that usually usually uses HTML, CSS, and plain JavaScript. This is called a static website, and it's served directly to the browser with no server-side processing, just a simple website. Then there are dynamic websites. These are the websites that are running actual systems, executing server logic paths through Node.js, APIs, Python scripts, connected on databases, and the content is generated on demand. When nothing is being asked but from the website, so the website is, let me say, off there and then. But when something is asked, then an API call is called upon, then the information is brought within the system. Everything here values differently. A static website, all the information that you need is within that static web page and nothing else. But a dynamic site or code base has a front end, back end, and also has databases connected to it. So, what is a global edge network? So, global network, a global edge network is a network that copies and stores your static web files across hundreds of distributed points of presence worldwide, syncing layout assets from primary server to regional web data nodes near the user. Most cases you might wonder, like AWS has different servers within different continents and different countries. But when a person like in maybe Uganda is to access something, a person accesses it maybe very fast, and you wonder how is it possible. AWS might be having its main server maybe in the US, but has a distributed network of servers within different countries, whereby a person within Uganda, Africa, when he calls upon a website hosted on AWS, the person not be calling upon the actual information stored within the main server. Will be calling upon the information from the closest server to him. Maybe Africa's closest server is within Asia. Instead of calling data from maybe the US servers, now the guy from Africa will be calling in data from the Asian servers that are closer. This is maybe the entire explanation of the distributed points of presence. So why edge acceleration matters to Africa. The problem, hosting code exclusively in single remote zones like maybe North Virginia introduces data transit delays for an African client, but the fix is structuring file copies in regional network hubs, dynamically reducing the latency for African users. This is what I was telling you about having the distributed network of servers within the different countries, whereby when calling upon the information, you don't call from maybe the main server, but the server closest to you. Hope everyone is following.
Yep, we're on.
Right. So the next slide is all about the transport transport encryption layer security. This is the SSL. Most cases when you go to a website and you're about to access a website, they might show you that this is a harmful website and maybe opt for another option, or are you sure you want to proceed? Most cases that means that that website doesn't have an SSL certificate. And SSL stands for the Secure Sockets Layer. Modern cloud systems provide automatic provision of free SSL certificates, converting address from unsafe HTTP routes into secure encrypted HTTPS links. You might There is a difference between HTTP and HTTPS. Most cases when a website is on an HTTP, that means that website doesn't have an SSL certificate. And in most cases when you're buying a domain, let me say from Namecheap, an SSL certificate must be included, and that is one of maybe the products that they tell you to include within your cart when you're buying a domain. This an SSL or a secure socket layer is a standard security technology designed to establish an encrypted link between a server and the client, so that when you're accessing the website, all your information that you input within the website is secure and not available to hackers. Hackers can't easily access your information just because the website itself has an SSL certificate. And this is one of the good features that modern cloud services offer. I think Aaron talked more about the encryptions within his video. You can check it out on YouTube as well to learn more about this. So the summary of the infrastructure choice. You should look for less friction, security built in, and an instant deployment. Because most cases when it comes to deployment, you might opt for maybe the servers themselves for the infrastructure as a service. When you opt for that, you must be having cloud engineers, DevOps specialists, so as to make the entire operation smooth. But if you're not opting for that, that's why you go for the PaaS, the platform as a service. And these platforms as a service offer less friction, built-in security, and the instant deployment. So choosing PaaS infrastructure removes the system engineering friction, enforces modern security out of the box, shortens deployment time to seconds. It's just a click and your website is live. So the platform as a service ecosystem, we are going to focus on mainly 4 hosting tools for quick deployment. That is Vercel, Netlify, Render, and Railway. So this is brief information about them. Vercel, as you call it, is the speed king. It's optimized for speed, optimized for high responsive user facing frontends with Next.js, React, and offers instant previews, global edge performance, and zero server configuration workouts. Then Netlify is mainly used for static websites, and as they say, it's the front end factory, excellent for landing pages, simple portfolio layouts, and static frameworks. Famous for instant visual drag and drop mechanism and out of the box contact form handlers. So then there is Render. Render is the Swiss Army knife. People that don't know the Swiss Army knife, this is the knife that has many, let me say, many compartments. Is it a knife that has maybe a file, uh, has maybe a spring to it, has okay, it's a multifunctional knife, and that describes Render. Render is multifunctional. It's perfect for background computing platforms with backend and APIs, Express, Python, Flask, Django, and it handles long running services that need to listen for traffic 24/7. If you're building a full stack application, Render is the best to use. And there is Railway. This this is the database canvas, a modular system tailored for data storage management, PostgreSQL, the Redis, MySQL, and provides an interactive layout board to link services like puzzle blocks. But for me, when I'm to go for deployment, I opt for Vercel or Render. And you can actually use two platforms at a go. You can deploy your front end on Vercel, then the back end is deployed to Render. But my major focus today is going to be Vercel because it's easier than all the rest. Deployment strategy and version control. The version control was explained fully last week by Aaron, and his video has been posted to YouTube. So from selecting the right hosting platform to pushing code through Git and GitHub, this section is going to cover the full deployment pipeline from the architecture decisions to the live infrastructure management. So this is maybe a table showing how to use each and every one of them. If you're building your portfolio is HTML, CSS, opt for Netlify because it's easy. Just drag and drop your file into Netlify. If you're building interactive web pages, web applications that are React or Next, you can use Vercel. Backend engine services like Node, Python, Render, and relational database systems use Railway. I can show you how all these systems look like. Start with Render. So this is Render. I'll send all the links in the chat. Render is just easy. Most cases, if you're signing into such a platform, you just connect with your GitHub because it will be easier to deploy all your systems just because you're connected to your GitHub. This is Vercel. Vercel is highly advised to continue with GitHub when signing up because Vercel will immediately pick up all your repositories and show you how to do that. This is Railway. Also, Practice that's highly advised to developers. That's when you come into web application development. Platforms like Vercel offer you options whereby you can actually keep your environment variables. Those are the API keys safely and not exposed within your code. That's a practice that most developers tend to fail to do most cases in this era of vibe coding. You just build your website and you find that API keys are within the system. That's highly unadvisable. That's why platforms like GitHub have things like GitHub lenses that immediately detect when environment variables are deployed within your code and tell you that you should change this, then change that. Never bake sensitive keys or database passwords directly into your code files. Exposed credentials in your source code are critical security vulnerabilities. If committed to your public repository, anyone can access your public keys and your secrets so that they can utilize your API keys. Most cases, API keys are given to paid accounts, so person might access your API keys and use all the money that you have on your account, be it AI credits or even your server account. So there's something called Streamline DNS and custom domain mapping. Sites like Vercel, Netlify, Render offer you free subdomains, whereby your site will be maybe ashlycode.vercel.app. That's when you have used Vercel, or Netlify is the same thing. Same goes for Render, so that you can deploy your website and you can share it to anyone. Those are subdomains, but there are premium custom domains. These are the ones that you actually buy, and this be like Akili Kesho.com. That's that's a domain name. You actually buy that with your own money. So through the the platforms that I've talked about, they have automated DNS configuration settings. The platform handles the DNS records and the SSL certificate provision, giving you a professional branded URL with minimum setup effort. Those that don't know DNS, that's the domain name system. This one is the one that translates the human readable domain names into machine readable IP addresses. You might go to search maybe for www.google.com. That's something that's readable to you and that's a domain name. But when the computer is trying to understand where you're going to, you have to know the IP address of the website that you're trying to reach to. The computers won't understand the google.com that you've typed in, but rather we get the IP address that Google is at. Maybe it's on like port 142.296.08. That's an IP address. Without a DNS system, you wouldn't be able. You would have been able to remember each and every single IP of each and every website you try to visit, trying to recall each and every number perfectly so that you can visit the website. But with the with the DNS system, things were made simple. So now focus on the system debugging and runtime logs. When an application hits an unexpected error, platforms provide streaming console logs that let you trace the bugs line by line within the real system. These logs capture server output, error messages, and request details as they happen, giving you immediate visibility into what's wrong in the production and what's what's needing to, to reproduce the issue locally. I have screenshots for all that within the presentation. I'll show them to you later, and how you can actually fix all that. Infrastructure strategy principle. So as I told you, platforms like Vercel and Render can all be used at the same time. You can use Vercel or Netlify for your front end, and you focus your back end to render or Railway, since platforms like Render and Railway have reliable runtimes and are dedicated to such software applications. The backend layer runs sustainably sustained compute processes via Node, Python, or databases on dedicated backend platforms like Render or Railway. Then the visual interfaces with HTML, CSS, and React, which are lightweight, can be run on platforms like Vercel or Netlify. So, as earlier, as we had earlier on said, the version control was discussed further within the video of week 1, but I'll give you a small brief on how version control is used before deployment. Before any code reaches a deployment platform, it must pass through version control. Git and GitHub form the deployment bridge. Actually, GitHub itself can be used for deployment through GitHub pages, but GitHub pages is also advised for only static websites like the portfolios, the simple one page websites, and the official secure cloud vault for your code blueprints. That's the GitHub. Platforms connect to GitHub, not directly to your laptop files. So that's the importance of GitHub in all this. GitHub is maybe the store of your code, and it's the one that the deployment platforms will use to access your code. So when you're going to deploy, there are stages or steps that you must follow. The platforms don't access your laptop files directly. They connect to GitHub, which acts as the official secure cloud vault for your code blueprint. Every deployment is triggered from a committed state in your GitHub repository. From your GitHub repository to staging your files through Git add and creating a snapshot of your files to GitHub through the Git commit, then uploading your files to GitHub through Git push. This workflow tracks code states from the local environment all the way to the live code, ensuring that every deployment is tried and verified through a vision commit. So most cases when you're committing maybe an HTML CSS website, platforms like GitHub or any other cloud deployment platform, the typography actually matters. The naming and architecture project workflow, the index.html rule. Your root entry home file must be named exactly small I index.html file strictly in lowercase. Non-standard names like index.html in uppercase or home.html cause platform routing errors. Most cases, assume you're going to use GitHub pages. GitHub pages can't pick up an index.html Well, when it's in uppercase, GitHub pages will show you that there is an error and your platform can't be deployed unless you change from the uppercase to lowercase. This is a rule and nothing else can change this. So before entering the project workflow, you need to first initialize your Git, launch your system terminal, and change directory files into the source code folder. But most cases, if you're in VS Code, you're already in the folder, so it's a matter of just opening your terminal. Now, so this is a screenshot of me committing my changes to GitHub. As I first told you, you have to start with git init. This is initializing your repository within your local machine. Then the git add. If if you want to maybe add a specific file, you use git add, then the name of the file. But for me, in this time round, I was going to commit each and everything. So it's git add space then a dot. This will ensure that each and every file within the folder is to be committed. So from git add you go to git commit. So it's git commit then space then dash then a message. This most cases you need to, as a developer, you need to document when you're working in a team. Let your teammates know that the updates that you have made are specifically for this. You have worked on this, maybe change the background color, maybe done this or this. So git commit, from git commit it's git push. That's if there is no change within the repository, but if there is a change you have to first pull. But all that was in the video of git and version control in last week. So activating git and establishing your identity was also from last week's encounter. So you initialize that git init, git add, then your identity. That's if you have not logged within, if you're not logged your account within git bash. So let me see. This one is also git commit. So this can also be used to log all the changes that you're about to commit to GitHub. So here we're going to learn how to capture your work and push it to cloud and deploy it live. So capturing history snapshots, stage your change directory element to lock down your first clean remote local snapshot. This creates a permanent record of your work at this point of time. Staging changes, I had earlier told you, that's the git add. If this is for all the files that have been modified, but if you want to select a specific file, it's git add, then the file that you want to commit. Then the commit message records a named timestamp snapshot of your stage changes. This tells your fellow developers that I've done this and this at this and this specific time. Show you that later as well. So git pull then git push. So I earlier on said git pull, this is knowing if your repo is up to date, and mine was up to date, so they show me already up to date. Then git push origin main. This is when you're pushing to the main branch. But if there is a side branch, maybe call it front end. If you push to git push origin, git push branch, then front end. So this is the entire process of, of committing your changes to GitHub and before deployment. Hope I'm loud and clear and everyone is following. You can drop emojis within the chat. So great. So establishing the GitHub Cloud Vault. So it's going to GitHub, creating a new repo, then assign a project name, and most cases you have to leave the repository as public if you want it to be accessed by maybe your friends or any other person. Because you can either keep a repository public or you make it private. Private repositories are available to only you and no one else. So, as I said, a public repository allows anyone to view your code. This is ideal for portfolio projects and open source work. Then, private repos are available for personal projects and maybe company projects that you don't want to showcase. And most of us are open source contributors here and really available to collaborate. So, so this is pushing your code maybe as I earlier on said, git remote add origin. This is when you're pushing to a new repository that you had never committed in. I'll show you that because you're going to have a practical demonstration of all that later. So branch, this is when you want to rename a branch maybe. This is when you want to push to the cloud vault, which is GitHub itself. So verifying sync and deployment prerequisites. So verify the remote sync. Reload your GitHub repository browser to see if your code files, directories, or commit history logs are fully visible within the cloud vault. This is confirming that your deployment was actually successful. So before any automated hosting system can build a live link of your local files, you must securely sync your GitHub repository. This is why I was saying most cases you should sign up with your GitHub repository when you're opening up an account on a past platform like Vercel, GitHub, Render, or any other. So I have screenshots here on how the platforms look like, but I'm going to take you through Vercel, the step-by-step hands-on deployment. The two proven methods to take your code from GitHub to a live public link. So Vercel, the account handshake and project importation. You sign up via GitHub. Go to Vercel, sign up, then but continue with GitHub to authorize automated access tokens within your account safely. If if you don't sign up via GitHub, it will be a complicated process to connect your GitHub to Vercel via email. So it's advisable to sign up with GitHub itself. So inside your Vercel account console, you have the primary button, Add New, to select a project to begin from. So this is how Vercel looks like when you have used your GitHub account. As you see on this arrow, this shows you how to connect. This shows you that my GitHub account is connected. But if I want to change, I have to come to this drop down arrow, then select, then I change my account details. But since my GitHub is connected, these are the different repositories that I have on my GitHub. And if I want to deploy any of them, it's just a simple button press, and the repository is made live, and I have a link within just a maximum of 2 minutes. So I say it's on Vercel, it's select repository, then execute deployment. Vercel scans your GitHub cloud profile and lists all your code repositories, locates your project name, and by the click of a button of import, everything is done. You leave all the configuration completely to their defaults, click, click the large primary and root deployment call to action button, and trigger the build. So, so this is how your dashboard will look like after logging in into Vercel. These are some of my active projects, and you can see the links are there. You can check them out as well. But when you're logged into Vercel and you want to create a new project or add a new project, you just come here to the add button, to the drop down, go to projects, then you'll be redirected to the other page that you saw first. But sometimes you might encounter errors during deployment because it's not a matter of committing to GitHub and everything is successful. When you commit and your commits are successful, you get something like this: ticks, green ticks to your work. But when something is not successful, you might get a red X, and it looks something like this. And when you get a red X on your commit, that means that even on the deployment, it won't work. So a successful deployment is when everything is green. When there is red, your deployment isn't successful. And after deploying a project, Vercel usually shows you something like this: congratulations, you have deployed a new project to your account. So same goes for Netlify. Netlify, you also sign in with your GitHub account. You just drag and drop your folder, or even just from your local repository into Netlify. So in development, it's all about code, deploy, then from deployment there will be continuous integration to check out if the different parts work, to add new features, That's where the CI/CD comes in. This is continuous integration, continuous deployment. So Netlify as well, it reads your repo, analyzes it with zero configuration, gives you a live link. Live links of Netlify are project name, then .netlify.app. Same goes for render, but render kinda takes a bit of time. You log into render, and render most cases has a paid version and free version. But when it's a web app, you go to new, then create a web service, then connect the project repository, then you type the command node server.js. That's an example. Then you click deploy, depending on the type of project that you have. And as you see, render is ideal for deploying backend API services and full stack applications. By connecting GitHub repositories, render automatically detects your project and runs a specified startup instruction to launch the server. The platform handles provisioning and keeping your services running through a streamlined path from code to a live API with minimum setup. So Railway is ideal for relational databases. Railway makes spinning up a production-ready database effortless. You just log in, select your engine, then Railway builds a secure and instant, non-complex setup with no manual configuration required. Just log in, new project, choose the engine. If your database is PostgreSQL, if it's a Redis database, or if it's an ASICO database, then Render will immediately build it for you. So the CI/CD automation, that's the continuous integration, continuous deployment. So this is a scenario. Imagine your app is live, but you find a typo on the home page. You don't have to repeat all 50 layout or server configuration steps. Rather, you fix the problem within the line of code, commit to GitHub, then from GitHub, platforms will immediately pick up your changes and deploy themselves. That's the continuous integration. Then you look for the change, for you fix the change. Then when you commit to GitHub, the cloud platform like Vercel will immediately pick up the change. Then it will deploy. So that's the continuous integration, continuous deployment. Continuous integration, that's automatically compiling and testing the code updates every time you push changes to GitHub. Then the deployment, automatically delivering the checked code updates straight to the servers hands-free without any manual intervention. Everything is done automatically. That's the that's the superpower of the CI/CD automation. Automatically compile and test updates, then the CD will automatically deliver checked code to the live servers. Then your application is live without any need of you going to set up maybe change the logs of the server or any other thing. So webhook infrastructure observers, then the seamless zero-time releases. When you link GitHub to Vercel or Netlify, they install an invisible messenger called the webhook. Webhook acts like a link of communication between platforms. Even in website development, there is a stage whereby you learn about webhooks. When you push code changes to GitHub, the webhook alerts the platform to deploy updates instantly, no manual trigger needed. The system keeps your old site version fully online for users while compiling updates quietly in the background. The user swap happens seamlessly with zero downtime. Visitors never experience any outage during deployments. So this is the magic of the past platforms. No manual intervention and everything is seamless. So these these are the production fix commands that are usually used in deployment. To patch the typo or changes or color or UI color live, just run a standard terminal git cycle routine. The git add, git commit, that's git commit m with a message made as you see, patch the type on the home screen, then push to origin. This is the main branch. Git add, this stage is all the modified files for commit. Then commit, this records your changes with a descriptive note. Then push, this triggers the webhook to deploy instantly. So the professional production cleanliness checklist. These are things that you must at least preview before committing. As I had earlier on said, the lowercase root pages, verify that the root page, which is like index.html, is in lowercase, not uppercase. Ensure that if you have things like pictures or any other, the path is actually accurate. Maybe it's in within images, as you have seen, it's within a folder called images and the picture is called pic.png. Ensure that it's the images folder is within the actual folder that you're going to commit to GitHub before doing any other thing. And ensure that the environment variables are out of your files, or ensure that they are not hard coded within your lines of code. Platforms like Vercel provide environment variable tabs on your platform so that you may never commit your secrets within your repo. Now, so this is the end of my presentation, and now I'm going to take you through the deployment. Any questions? Anything before we proceed?
Looks like there is no question. Maybe people are excited for the next.
Uh, right. So me and my team designed a simple hello world project to deploy with you today. So this is still on localhost. This is how the project looks like. Welcome to Akili Kesho internship training. So welcome to week 2 training, moving source code from isolated localhost sandboxes to automated edge accelerated public cloud deployments. the CI/CD and cloud architecture. Instructors, it's me and Natozo Matha. So you can click on this button and it's actually linked to my personal portfolio project and it's hosted on Vercel. As you can see, it's my name then .vercel.app. That's the subdomain that Vercel gives to you when you deploy with them with their subdomain. So with time, you might need to develop a portfolio project. This is an example of a portfolio. This talks about you, projects that you're working on, who you are, your experiences, the projects, something like that. So I've already created a repository on GitHub, but if you don't know how to create a repository, it's just a simple thing. Come here to create new repository, then you create a repository. So this is the repository. And now we're going to show you how to actually collaborate with your fellows on such a project. First and foremost, you need to know how to fork a project. Forking is just like copying the entire repository and pasting it on your own. You copy someone's repository and it appears on your own repository. You just come here to this and you make a copy of that repo itself. You can change the name, but the the owner always still appears on the fork. Let me show you an example of a repository that I fork. So now this is an example of a forked repository. As you can see, they are showing you forked from this and this is the name of the person that I forked the repo from. So that's also something that you need to learn, because you might admire a project and you feel like you need to maybe make a similar project. Forking enables you to do that. So as you can see here, I'm the only contributor, and if any of you guys, I think last week you created repos, going to add contributors to this repository. Go to settings, then collaborators. GitHub nowadays became more secure because it was hacked and they implemented a 2FA on it. So everything you do, you have to first. So, so now on collaborators, here as you can see there is no active collaborator, and here there is manage access. On add people, this is where you can search for the person that you want to add as a collaborator. Maybe I want to add Evans. You can search for their for the person's name or username or even email. Evans, what's your username? Bartholomew
Evans Bartholomew 20 hyphen web.
Evans. Yeah. So is this then you add him as a collaborator. So here you have sent him an invite. Until he accepts the invitation, he's not yet a collaborator, but when he accepts the invitation, he's a collaborator. But to appear on the collaborator section, he or she must add something to the repository to actually appear. Let me add maybe Martha. Martha. So I've invited all these people and now they are to be collaborators. That's only if they accept the invitations. If they accept the invitations, they'll and add something to the file, they will be collaborators. So let me take you through the deployment. As they accept the invitations, then maybe Martha will edit something from the deployed platform.
Actually, just a
Yeah.
minute. Maybe Martha can share her screen and demonstrate how to accept an invitation, probably. Or I can do it.
Okay.
Like maybe Martha or I can share
Yeah.
our screens and demonstrate how one can actually accept the invitation, because our interns may not be knowing how to do that.
All right. So anyway, you guys can.
Yeah, I think Martha or Evans, you can simply display, and then when you're done showing the notification and how you act on the notification, then he can show his screen again. I should call. Yeah, so I think Martha is saying that Evans can demonstrate because she already accepted hers.
Can you hear me?
Yeah.
All right, so I think all of you can see my screen, right?
Yeah.
Okay. So when someone sends you an invitation, this reflects on your email, the email that you actually used in the registration or in the signing up of the GitHub account. So let me show you, let me take you straight to that. So as you can see here, it's an Iwasima. Ashley Cole invited you to collaborate. So I can view the invitation from here directly. or I can simply go to my GitHub account and tap on that. So let me view it from here directly. So this takes me directly to accepting the invitation, but I wanted to show you how I could actually do it when I've gone to my GitHub account. All right, since I already have a shortcut here, let me tap on that. So when you want to view an invitation, I think most of you can see this icon here with a blue dot. So this is where you tap. So when you tap on that, these are some of all the invitations that have been sent to you, or those that you haven't yet accepted will all reflect here. So as you can see, John sent me an invitation that I haven't yet accepted. Then Ashley Cole has also sent me an invitation that I'll have to accept, and it's what I'm demonstrating. So you simply tap on that invitation, then you accept. So when you accept, you can now collaborate on that. Yeah. Basically, that's how we go about it. Hope I've been clear.
Yeah.
Yeah, I was wondering, does he have any file for you to fork from his side? You could do that when you access, then you fork the file, and where do you put the file? You could do that simply, and then you can
Sorry.
come in and decide to make edits, and then yeah.
Sorry about forking. I had initially forked this repo in the morning when he sent me the link to it. So I don't know if I doubt I'll be able to demonstrate it from the
Evans,
beginning.
you
Yeah.
can fork maybe another repository just to show them how to fork.
Okay. Okay. I'll be forking maybe probably another repo to show you how to fork. Now I'm forking this. As you can see, this brings me to the home page of this very repo that I forked. Sorry, that I'm about to demonstrate how to fork. So there's this icon here that probably looks like a two-mouthed fork, as you can see it here. So you basically tap on that. So when you tap on it, like what Ashley was demonstrating initially, you can add a description, but most times it comes in with the owner's name. So I can create a fork here. Oh, sorry, I haven't yet chosen an own. So I can choose how to fork it, where to fork it from, probably this. Then you can add a repo name to it if you want to. Then fork. So that's how I can, that's how a repo is forked. Ashley?
Yeah. As you can see, he forked the repository using another account, and it still appears here showing that forked from Ashley Cole, then this. If you want, you can change your name of the repository, but it will continue showing that you forked it from somewhere else. That's basically the forking part. You can also start a repository. That's if you like the repository and want to know more about what's happening within the repository. Also, you can watching the repository. This is all about being notified if there is any change within the repository or any activity that happens within the repository. You'll be notified. That's the watching. So let's now proceed to the actual deployment stage. Evans.
Okay. So maybe now what I'm going to do is I'm going to try editing the README so that it can reflect, so that I can reflect as a contributor on this. So I can tap on that pencil-like icon that I've, sorry for, okay, this pencil-like icon. So tap on it.
Yeah. Evans,
Yes.
I think you should first go to the main repository so that we work on the main repository other than the fork branches.
Okay. It's okay.
Yeah, I think we've lost someone speaking. Yeah, Evans.
Yes, I'm on it.
Oh, okay, cool. All right.
I'm trying to get to the main repo, the Akili Kesho deployment. Okay, so this is our main repo. Ashley, right? Ashley.
Yeah, I feel like, is it a network issue or what? Because my screen is still static. First, go hit the back button, maybe.
Hello, can you guys get me?
Yeah, we can hear you. Maybe what you can do, you can stop all the share, then you reshare.
Okay.
Yeah, nice. Now you can reshare.
Right. Is all of you able to view my screen?
I think I can see. Well, actually, Carl, are you able to see?
Yeah,
Maybe
Yeah,
you
I
could
think
get
you're.
that. Okay. I see Joseph has also dropped an emoji. All right. So this is the main repository of this project, the simple demo that we are working on. So as you can see right now, there is only one contributor, Ashley Cole, and he has invited two more. So for me to reflect as a contributor down here, I can make some simple changes to it. So let me make a simple change on the README. Now, to edit the README, I can tap on this pencil-like icon. Okay, so I can type on that. Maybe as you can see here, this README doesn't have a title. So I can add a title and be like, Akili Kesho. Let me say mentorship. Okay. So when I do that, see this green like icon saying commit changes. I tap on that. Now you can add a description of the changes of the change you want to of the change you made. Maybe I can say added a title. Sorry. Added a title. Then commit the change. Okay. So from there, it will have to reflect that I made a certain change to the README. Now I would want to take you back to the main repo to see if my name actually reflects as a contributor. Okay, this is it. So this shows just right now I made these commits, updated the README. Yeah. Now, initially, it was only showing Ashley Cole and it was only showing Ashley Cole. So it also shows me as someone who has updated the README. So I'm a contributor to this project. Now there are two contributors reflecting here. So basically that's how someone can get to contribute on a project. And I would also have, let me say you want to have the folder on your local disk. Aaron took us through that last week, the cloning of a repository and all that. So I wouldn't want us to waste time demonstrating it again, unless you guys weren't well conversant with it.
I think it's
Hello?
fine. Since it was covered, it should be in the uploaded video. They can check it out.
Okay.
Yeah.
So yeah, basically that's a simple demo of how someone can contribute to a project. Yes. Ashley, is that all?
Yeah, I think that's all. But now I'm going to show you how to deploy through version control, then also contribution through version control. By Martha will at least maybe change something within the code, then you see how to actually reflect as a contributor through using version control, not from GitHub itself. Think Evans, let me share my screen, then can unshare. So this is the file that you're going to be working on. It's basically inline CSS and JavaScript within HTML, one single file, which is Akili.html, but as I earlier on said, this isn't a perfect name for a repository. If it's one node file, it should be index.html. So I'm going to change that. Folder, it's folder. So this is our file. I'm going to change the file name here. Index.html. So this is our code. And now we're going to commit to GitHub. You have to open terminal, depends on the PC, but mine is control, then yes, or you can come here to this, then terminal, control shift, yes. Maybe let me show you what I'm going to use. So these are the commands that we are going to use right now. It's git init. So as you're seeing, this has initialized an empty git repository. So from git init, go to git add, because I want to add everything within this folder. Git add space then dot. So everything has been initialized. Then it's git commit, then then a message. It's space in. So so the message is going to be adding the first file to the repository. From that, it's I think here you can either use the git branch main. This is naming the main branch main. So let's use that git. So from this, now since you are going to add to a repository that you have never committed to, going to use git remote add origin, then the URL of the repository. Git add first refresh this. And as you can see, all the two that accepted the invitations are now labeled as collaborators. So looking for the link. So this is the link of the repository. We need this. Copy. The link of the repository then dot git. So from that, we push. Since you are pushing to the main branch, its origin main. Now since I have different GitHub accounts logged in within my PC, you select the one that you want to use. All that the accounts have okay. Let's fast pull because so now let's again push. Let's see how many branches have we created. And one. Most cases there are conflicts when one branch create. So it's rejected because the tip of the current branch is behind. If you might counterpart, this is a good nothing. Let's try git one. Let's try this because that's try. Mm. Mm. Counting anywhere here was mm. Let's first update the repositories. Mm.
I think you may want to check the existing branches.
Yeah, the branch, it's only one branch,
Yeah, you
and
could try to select that and then to specify.
let's see. It, um, let's go into my related histories. So the conflict is they are refusing to merge related histories. So, so I think here we need to just post code or or redo and delete allow unrelated history. I think now the merge is complete. So, yeah, I think now it's successful. Had created the repository and the files were separate. So now there are conflicts within the repository. So the file has been committed. It's here. And see everything is now here. Oh, version control is something else because trying to deploy this version of the website live and you guys can test it out. Let's use Vercel. So as earlier on said, continue with GitHub and now I need to create a new project. So add new project, and as you can see it's already here. It's just a matter of one click. Import. So let's change the name here to make it shorter. So deploy. Just within a few minutes, it's live. This is our subdomain link, and you can check it out right now. Yeah, that's it. So let me share the link in the chat. You guys can also check it out. It's Akili slash it's Akili. Yes. Then rogue.vasel.app. Now this is the actual deployment. Let's go back to GitHub itself. Refresh this. And as you can see, GitHub has already picked up the subdomain and it's actually here and it's showing deployment production ready 1 minute ago and it's successful. But most cases there are even errors in the deployment, and if there is a red X here, that means that the product hasn't been deployed. go back to Vassal and see the stats here. You can add your custom domain from here. Deployments. All this is handled by Vassal itself, but this could have been rather a wrong process if it wasn't because of Vassal. And as I earlier said, the environment variables. Vassal offers you a space whereby you can add an environment variable so that you don't hard code them within your code base. Show you an example of all that. Make a project. Yeah. So as you can see in the project, I have environment variables here. This database, Gemini, all this within different projects. All these are sensitive and shouldn't be exposed within your code. The API keys. You learn more about them from Joseph's session, and maybe Martha can show you how to now pull all these changes that I've made maybe out as something within the project. Maybe Martha can add like welcome interns to Akili Kesho to this welcome typing message, just to show you as collaboration through version control. Martha, is it possible? Hey, Martha, are you still with us?
Maybe she has an internet issue. We are left with about 15 minutes, so I think we could find a way to do that. Or you could do it with Evans, unless Martha comes back on.
Evans, are you there?
Yes, Ashley.
Yeah. So maybe you already have the repository. You can clone it. After cloning it, maybe I'll show you where to change so that now you then commit from your side using version control so as to appear this side, so as to showcase the CI/CD, continuous integration and continuous deployment.
Okay, but shall we be able to do all that within the remaining minutes? Mr. Edson?
I don't know.
Okay, what we can do, we can shift that to next week on Monday, and next week on Monday we should repeat the demonstration, but from the collaboration part basically and deployment part, and we don't go back to the slides, but we just pick up from right there. You could work on a few programs, and then you can see how to work out that. So I think it's okay. We can keep it for next week. Ashley Cole, you can find a way to close the session of today from what you can.
So, all right. I think all you guys have to do is check out Vassal, because Vassal is my go-to for deployment, and Render. Vassal and Render are the ones that I use most. So Vercel and Render. Check them out. They are easy to use. Render also has quick links whereby it's easy and accessible to any. Try maybe make a simple static website, host it there, and give us your views of how the deployment session was. If there is any other question, you can maybe request for the mic, ask, and tell us how the session is so far and what you guys have understood through this session.
Thank you, Ashiko. That this was an amazing session, and I know when things get too technical, people tend to look at their PCs and they're like, okay, where can I start from? But anyway, we shall get there. I believe everybody will pick up. Next week we expect more people to come, and this team will be coming around once in a while. Evans will come, Ashiko will come, Aaron will come at least once a week for a one-on-one kind of consultancy. And also Martha, I think Martha has had a lot of network issues. No, that's very okay, Martha. Next time it will be good, we believe. So I think we can close today's session here. We have a session at 2 p.m., so we're creating time for you to have lunch, chill out a little bit, and then we come with a session with Evans, which is going to be much on AI. So I believe it's going to be very interesting since you're all familiar with AI. Now, one thing to mention before we close, in most cases during mentorship, we always have people who are way ahead in terms of knowledge and skills. And then we have people who are basically basic and starting. And then we have intermediary people. So you find that to balance that entire boat is to go back to basics, is to mention things as if people know nothing, as if you're talking to people who are from a different, let's say, course unit, basically. Because if you assume that maybe people know, you skip out on the important things they need to know. And also, if you assume too much that they do not know, maybe at times, you might spend a lot of time on certain things. So, my kind request is the coming sessions to be more interactive. We would love to see interns chatting in the using the chat forum to send messages to find out ABCD, what you're doing, ABCD, and also to raise up hands. That's the only way we can tell that you're actually following, you're picking up. All the trainer is way ahead. Trust me, any trainer here is willing to go back to zero at any point of the training, if at all that's what you need, to pick up. So, so that is key. So some of the resources have been shared in the chat forum. I will upload this session towards the end of the week when all the sessions have been covered. But thank you. Thank you so much. Let's meet at 2 p.m. Not to make it so long for the YouTube. Bye-bye. Thanks, Ashley Cole. Thanks, Evans. Thanks, Martha. Connie, Namik, Joseph was on the call, might be on the call still. I'm just reading those I'm seeing on the screen. Potiphar is on the call, Rebecca, Connie on the call. So thank you all for being here. What happens in life, things start by not making sense, but then they end up making sense. It's more like a child born today. You speak words and they sound as if that is Greek, but then with time the child can speak the same that you speak. So thank you. We'll meet at 2 p.m. Bye bye.